A good strategy for graphing piecewise functions is when you consider where you're starting at for each piece of the function and where you're ending at. So if we're just looking first at x cubed, right, this is x less than 0. So if I'm graphing x less than 0, I have 0 and it's everything here. I'm starting at negative infinity for my function, okay? And then I'm ending at 0. And if I want the y value, I just plug in. So 0 cubed is 0. So that's where I'm ending. And then also because it's just less than, this is going to be open here. All right, so what it's going to look like then, it's going to look like an x cubed function. So normally I go 0, 0, over 1, up 1, left 1, down 1, left 2, down 8, right 2, up 8. But again, I'm starting at negative infinity, so I'm going to have an arrow from this end, but I'm ending here. So I can do an open circle. I can go left 1, down 1, and left 2, down 8 would be like somewhere over here. So I'm coming up, and this is where it would kind of have a point of inflection here, and then it would go up this way. Okay, so that's my x cubed. And then for x plus 2, okay, I'm starting at 0. All right, but this time I can actually equal 0, and I'm going all the way to 3. All right, so that means my start, x can be 0, and that's going to be a closed point. And then at 3, that's going to be an open point. All right, the thing is I only know the x value of the two, but to get the y value, I just plug in. So 0 plus 2 is 2, and then 3 plus 2 is 5. So I'm closed on 0, 2. And then I'm open on 3, 5, 3, 5, that's open. All right, and then this is a straight line with a slope of 1, so it's up 1, right 1, up 1, right 1. All right. And then my last part of the function is just a horizontal line on negative 2. And for this one, I'm starting on 3, and then I continue going forever. So I start on 3, and then we're going to infinity for our end. But when x equals 3, y is going to be negative 2 because it's a horizontal line. It's going to be closed because of the equal to part. So we have 3, negative 2, that's closed, and it's just a horizontal line going to the right. And that's going to be our piecewise function. So next we're going to use this and we're going to evaluate it. So when we have f of 0, what this is telling you is that this is 0. So we can look at the graph, and notice I have 2 points where x is 0, but this is open, so my point must actually be 0, 2. Okay? If you're using the function notation to evaluate, you would go through and be like, oh, x equals 0 is not in this set, but it is in this domain set. And so then you would plug in 0, 0 plus 2 is 2. All right, for f of 4, we do the same thing. We can look over here. So if I have x equals 4, that's right here, and I can see that my answer is negative 2 when x equals 4. So I'm looking for that point for negative 2 here. Or we can come over here, and 4 is in this domain, x greater than or equal to 3, and then you can see the answer is negative 2. So then for f of 1, looking in the domain sets here, we know that it's not in this part, but it is in this. So you would just plug that in. And for f of 1, 1 plus 2 is 3. You could also refer to your graph when x is 1, y is 3.